Hello future data scientist, my name is Pratham Chandratre and welcome back to Mastering Machine Learning series. So guys, imagine you are blindfolded, standing on top of a mountain and your goal is to reach the bottom of the valley. You can't see anything, but you can feel the slope beneath your feet. If it's steep, you can take a big step, and if it's gentle, you can take a smaller step. And that's what exactly gradient descent does in machine learning, guys. It actually helps us to find the bottom of the cost function, the global minima, step by step. In this video, we are going to understand about the convergence algorithm in linear regression. So let's get started. So guys, in our last video, we have actually saw about the cost function. The cost function basically tells us that how bad or good our line basically is, guys. We have also seen gradient descent optimization with this beautiful chart, guys. But here's the challenge. With real world dataset, guys, we can't just test every possible slope manually. We need the smart way to automatically minimize our cost function, guys, and that's where exactly gradient descent becomes our hero, guys. In this video, we are gonna see, we are gonna learn, we are gonna understand about the convergence algorithm in linear regression, guys. What is exactly convergence algorithm and how do we exactly converge to a point which we basically called as this global minima, guys. In a step-by-step manner, we will understand it in depth and in detail way, guys. Now here basically we will optimize the change of our theta 1, guys. Now what is exactly theta 1? If you have watched the previous episodes of linear regression, you are very confident that what is exactly the value of theta 1 means what is exactly theta 1. Basically guys, theta 1 is known as slope. So here we will optimize the change of slope. What is equation of best fit line, guys? Equation of best fit line is basically h theta of x equal to theta naught plus theta 1 x1, where theta naught is basically intercept, where our best fit line cuts the y-axis, and theta 1 is our basically slope, the slope of our best fit line, the slope of our equation. So theta 1 is basically known as slope, guys. And what in the convergence algorithm our main aim is, guys? See, in the convergence algorithm, our main aim is basically to optimize the change of this slope. Now, why we want to optimize the change of this slope? These all things we will discuss as we move ahead with a diagram and everything I have noted down for you, guys. Now, what is the equation of this convergence algorithm, guys? See, here we will basically first of all repeat until convergence. Until convergence means where we have to actually converge, guys. See, we have to actually converge to this global minima. Now, why we have to actually converge to this global minima? Because this global minima is the point, guys, where our error rate will be minimized. Because at this point, the value of our cost function will be 0. And when the value of our cost function is 0, at that time only our error is minimized, guys. So our main aim is basically in linear regression is to minimize the error. So we have to repeat until convergence. Until convergence means until the point where we will reach to global minima, where we will actually reach to the global minimum point. So what is, so we will until repeat this equation. This equation we will repeat until convergence, guys. What is the equation? Equation basically says that theta j equals to theta j minus learning rate. This symbol basically means learning rate, derivative of j of theta j upon derivative of theta j. Now why we are actually using here a derivative, guys? See, I will explain you each and everything step by step. First, let's understand what is this symbol, guys. This is basically known as learning rate, guys. It actually decides the convergence speed. Now we will understand more about this learning rate in our further video, guys, when we will understand more about the slope, more about this derivative. After that we will go ahead and understand about learning rate, so that you get more understanding that why actually we are using learning rate here. Now what is this derivative of j of theta j upon derivative of theta j, guys? See, this is basically known as derivative. And what is derivative here? Derivative is basically slope at a point. Now why we are actually taking this slope at a point? Just focus here. See, that if our best fit line is a straight line, guys, then the slope is very easy to calculate. The unit change in x, then how much unit change will be in y. That's exactly what the slope is, guys. But if the, you know, guys, the curve, if it's in the form of curve, now in the form of curve, guys, here the slope will be different and here the slope will be different. Then here the slope will be different and here also the slope will be different. So whenever there is a curve, in the curve the slope basically changes, guys. Now here slope will be different, here slope will be different, here slope will be different. So to find out the slope in the curve, guys, we basically use derivative. So derivative basically says that at this point basically what is the slope. So this basically we get with the help of derivative, guys. And what is our main aim? Our main aim is basically to reach to this global minima. So for this we basically take the derivative, guys. So that's why only in the equation we have basically taken derivative, guys, because we are working now with a curve. So in curve basically slope changes at every point. So at the particular point what is the slope, that we actually get it with the help of derivative. So this is basically known as derivative, guys, in order to find out the slope at a particular point. Now see, guys, here the equation is theta j equal to theta j minus learning rate, derivative of j of theta j upon derivative of theta j. Now focus here, guys. Now see, here I have drawn basically 2 points, and this is our global minima. One point is on left side of the global minima and other point is on right side of the global minima. And I have shown that this point has a negative slope and this point has a positive slope. Now there might a question arise in your mind. Okay, Pratham, I am basically understanding that one point is on left side of the global minima and other point is on right side of the global minima. But how have you stated that this is exactly a negative slope and this is exactly a positive slope? For that, guys, I am giving you a simple trick. The trick is very simple. If this, see, you are seeing this green color tangent here, guys. If the tangent's right side faces upward, now if this green color tangent right side faces upwards, at that point, guys, you will have a positive slope. And if the right side of the tangent faces downwards, at that time, guys, in the curve you will have a negative slope. So this is basically a simple trick in order to find out, the slope is basically positive or not. So if right side of the tangent faces upwards, then the slope is basically positive slope, and if the left side of the tangent faces upwards, then the slope is basically negative slope. It's as simple as that. Now why there is a need of this positive slope and negative slope, this also you will understand. Now main point here is this graph of basically theta j, and with respect to j of theta j, in the x-axis there is a theta j value, in y-axis there is j of theta j value. Now guys, focus on this diagram, entire diagram, very carefully. See, guys, this is one point and this is our second point. Now what do you think? Now if this point, the right side point of the global minima, if this point, we have to actually, our main aim is to reduce this point, means to reach this point to a global minima. Now what do you think? How can this point basically reach towards the global minima? It's simple, right? If we decrease the slope, what, again focus on the sentence, if we decrease the slope of this point, and then at that point if we decrease the slope it will come here, if we again decrease the slope it will come here, if we again decrease the slope it will come here, and if we decrease the slope it will finally reach towards the global minima. So what I am saying to you, if we decrease the slope of a point that is on the right side of the global minima, then it will basically reach towards the global minima. And now focusing on the left side of the global minima, the point on the left side of the global minima, this point want to basically reach towards the global minima. What this point want to do, guys? This points basically we want to increase the slope, as it's simple, guys. If we increase the slope of this particular point, it will reach here. If we again increase the slope, it will reach here. If we again increase the slope, it will basically finally reach towards the global minima. So the point on the right side of the global minima, if we decrease its slope, it will basically reach towards the global minima, and the point on the left side of the global minima, if we increase its slope, it will basically reach towards the global minima. Now again focus on this equation, guys. This equation is very important. What is this equation? Repeat until convergence. Equation basically says that theta of j, now repeat until convergence, repeat the equation same until we reach towards the global minima. What this equation basically says us? Equation basically says us that theta j equal to minus derivative or learning rate, derivative of j of theta j upon derivative of theta j. Now this derivative is basically the slope at this particular point, guys. And what is its value? Its value is basically positive. So see, here I have basically written, if we want to reduce the slope now what here we want to do? At this point we basically particular want to reduce the slope, right? Okay, so here we will basically reduce the slope. So what is value, guys? Theta 1 equal to theta 1 minus learning rate into positive value, because see, as the derivative value is positive, this is basically slope. Then we will theta 1 new equal to theta 1 old. Now this theta 1 old minus learning rate into positive value, as here we can see this slope basically has a positive value. It's as simple as that. And then theta new will be less than theta old. Now how it's less than theta old, guys? It's as simple as that, because see, if we will reduce theta 1 old value from positive value, we will reduce this value from a positive value, obviously this value will decrease. So our theta new value will be less than theta old value. So slope is getting reduced here. So now we will repeat this entire thing until we converge to a global global minima. So in this way guys, we will reduce this point towards the global minima. Now let's see if we want to increase the slope guys. Now see the point, basically the point which is on the left side of the global minima, the point on the left side of the global minima, if that point want to actually reach towards the global minima, what the point want to do? Point want to basically increase the slope. Okay, if the point slope will increase, it will automatically converge and reach towards the global minima. So this point basically has a negative slope. Now this negative value will basically feed into this equation, theta j minus learning rate into negative slope, and then negative into negative will become positive, and automatically our theta new value will increase guys. It's as simple as that. See here I have done this exact same thing. Theta 1 new equal to theta 1 old minus learning rate into negative value. Negative negative will cancel out and it will basically become positive value. So theta 1 new equal to theta 1 old plus positive value, automatically our theta 1 value will be less than greater than theta 1 old value. So theta 1 is basically increases. So here our slope is basically increasing guys. So when the slope will basically increase, it will converge to the point, it will reach towards the global minima. And that's exactly how this convergence algorithm basically works guys. Now your question, the main question, what is exactly this learning rate then? Please let us know about learning rate. See guys, learning rate in this gradient descent basically determines the step size taken at each iteration to minimize the value of the cost function. See, so what is learning rate? Learning rate basically determines the step size. The step size basically taken at each iteration. We have to basically repeat until convergence. We have to work in an iteration. So it basically determines the step size that is taken at each iteration to minimize the value of our cost function. A too simple learning rate actually leads basically to a very slow convergence guys. The time taken for a convergence will be very slow, and while too large learning rate can actually cause overshooting guys. It basically causes, in this way it basically causes overshooting, and it never reaches to a global minimum guys. So it actually causes overshooting to the minimum or divergence guys. So choosing an appropriate learning rate is crucial for ensuring algorithm efficiently finds the optimal parameters by balancing both the speed of the convergence and the accuracy of the convergence. So it should reach to this point, it should reach to this global minimum point, it should not converge here somewhere. So the speed should also matter, and accuracy of convergence should also matter guys. Usually we prefer to take learning rate value as 0.01 guys. So that's the learning rate value we basically prefer to take, which is 0.01. So that was all about guys, convergence algorithm, and that was all about mathematical intuition of linear regression. We have seen a lot. We have seen about cost function, we have seen about each and everything, we have seen the beautiful graphs, diagrams, and I have written so much of content for you guys. So this was mathematical intuition of linear regression guys. That was it for today's video guys. I will see you in the next one.